All right, here's an explanation of worksheet 3, a couple problems from it. So I'll do some of the problems, questions 1 and 2, and then we'll do the last one, question 8. So in this example, we've got a force at an angle. The question is to determine the components. So really, it's asking you to determine what would the magnitude of these two components be. So if we call this the force, if we call like the initial force the force, this one down here is the force in the x direction, and this is the force in the y direction. If you really think about it, if you add vectors together tip to tail, then the force in the x direction plus the force in the y direction would equal the total force. So in order to calculate those quantities, we're going to use our trig functions. So if we're trying to solve for f in the x direction, the angle of 50 degrees is the one we're talking about. So in the x direction, that's the side adjacent to the angle, which would have to be divided by the hypotenuse. So in order to calculate f of x, the cosine of 50 degrees equals the ratio of the force in the x direction divided by the total force, which is 12 newtons. So if you did this on your calculator, the cosine of 50 times 12, the force in the x direction is 7.71 newtons. If you try to do the same process for the force in the y direction is opposite of the 50-degree angle, so that means that the sine of 50 equals the force in the y direction divided by the hypotenuse. So the force of this angle in the y direction is the sine of 50 times 12, so 9.19 newtons. All right, question 2 is asking the same question. Figure out the components. Here's the force in the x direction. Here would be the force in the y direction. So the x component, and it happens to be true for both of these, but it's not always true. The cosine of the angle has to equal the adjacent, so the force in the x direction, divided by the hypotenuse. In this case, it's 15 newtons. So the force in the x direction is the cosine of 20 times 15. So 14.1 newtons. In the y direction, we have the sine of 20. So this angle, here's the force in the y direction. So the sine of 20 degrees has to equal the ratio of the force in the y direction divided by the overall hypotenuse force. So 15 times the sine of 20 is 5.1. Force in the y direction is 5.1 newtons. You can check these if you want. Use Pythagorean theorem, so 5.1 squared plus 14.1 squared should give you 15 squared. So, and if you do that, it does. All right, let's look at them. So in this example, the force of gravity and the normal force no longer are equal. So for us, we've got force of gravity that pulls down. And the normal force is always perpendicular to the surface. So in order to show the normal force, now we have forces that are not directly opposite. The only reason this box doesn't slide down the ramp, because we have two forces that are at an angle, like you would have a net force. The only reason it doesn't is because we must have some static friction in the opposite direction. So this is kind of tricky because we have three forces here. Now one is on like the y plane, so like it's on the up and down plane. But this one and this one are at angles compared to what we are normally used to. So something that can be really helpful is if you take your system and you rotate it so that we make the normal force up, the force, if you make 2 of the 3 forces be on the axes, then it's a lot easier to work with just one force that's at an angle. Okay, so now the force of gravity is going to come sideways. So this is just a problem-solving strategy to orient the forces in a way that makes it easier to work with 2 of them compared to 1 of them. And then if you do this, the angle between the gravity and the y-axis is the same as the angle of the ramp, so that happens to be true. So you can use that little trick to help you solve for the unknown. Okay, so if we're asking for the forces which act in the x direction, we know that the object is not moving, so that means that the forces must all be balanced. So in the x direction, the force of static friction plus, now we want the x component of the force of gravity. So those are the 2 things that must be equal, plus the force of gravity in the x direction. Those 2 things together have to equal 0. And similarly, if we're looking for the y direction, the normal force is the one that's going up and down. And if we add it to the force of gravity in the y direction, so if we add it to the y component, those 2 things have to be equal so that the object remains motionless. So that has to equal 0. So, question C gives us some numbers. If the mass of the box is 8 kilograms, force of gravity is 8 kilograms times the acceleration of gravity. So 8 times 9.8 is 78.4 newtons. So that means that 78.4 is that number. If we want to know the normal force, we need the y component of that number. So the FGY, in this case, 20 is your angle. That means the FGY is the adjacent side, which means we're going to need the cosine. So the cosine of 20 degrees equals the adjacent, which is the force of gravity in the y direction, divided by the force of gravity, which we already calculated for, 78.4 newtons. So 78.4 times the cosine of 20 will give you the y component of the force of gravity. So FGY, and in our direction it is down, so that's negative 73.7 newtons. So that means that the normal force is 73.7 newtons. All right, we will use a similar problem-solving process to solve for the force of friction. So in our case, instead of using the cosine, the force of friction is equal to the x component of gravity. So for x component of gravity, we need the sine of 20 degrees is equal to the ratio of the force of gravity in the x component divided by the force of gravity. So for this angle, this 20-degree angle, this opposite divided by this hypotenuse is the sine. So if you did that, 78.4 times the sine of 20, get 26.8. So the force of gravity in the x direction was 26.8 newtons. Because the force of static friction is in the opposite direction, the force of static friction is negative 26.8 newtons. All right, that's it for worksheet 3.